Yeah.
Okay.
The,
I think it's designed for you.
No.
Maybe
I haven't started anything.
Carry.
You do?
You know, since so far back in the past, but then maybe.
I'm so confused. Why they didn't work before?
I think it's not, I think it's because people have different decks.
It's so bad.
I mean, the other one had like.
The other
six
one, I
decks,
need to
though.
like,
Yeah.
well, that's one, but the other one had to like switch so many different windows. Before you can like share and stuff.
No, I think, okay, everything works fine. Sorry, we were a little bit like.
No, it's good to check. Okay, can we?
Yeah, maybe put this
Get
somewhere.
rid
Oh,
get rid
yes.
of this heinous thing.
Yeah.
Yes, well, there's.
That's-
Oh,
That is fun.
Here.
Yeah, I think this is.
Oh,
Sorry,
Like.
you can drive. There you go.
There's public parking.
Just fun.
I think if you hit the arrow, it should,
Turn off and go. And there's, no. there's a public
the
parking.
arrow on the left. Yeah.
It says.
You would have said it.
it is
It
completely.
says.
Okay.
I don't know, it's probably not normal inside.
Yeah, it doesn't know what to share. No, it does.
We'll put this away. Quiet.
Yeah.
On the side.
There's this.
It really was the most.
It's so annoying.
Let's do them both. Can you just, you look up there and make sure that all of your slides transferred correctly because they don't transfer nicely when I.
Or day, no, it's perfect, yeah, everything is.
I had to change them all,
Oh,
so.
really, okay,
Yeah.
weird, okay. We don't have to, yeah, no, thank you so much.
Yeah, no worries.
Everything is perfect, yeah.
So I tried to make them as close as possible
No,
to
no,
the original. but
no,
yeah,
thank you
just in
so
case.
much, yeah.
Okay.
And yeah, take sometimes to relax, search, it's like if you need something. So if you're saying that we'll found this one.
Wait, isn't that like Croatian? No.
I get very offended at that. What is this?
Oh,
I'm not very offended, I'm just joking. You, Gary, thank you.
I don't think so.
A cat very valiantly gave up her laser pointer for me and for me.
You just need the pointer, you need the slide the pointer as well?
I think just the pointer. Well, I guess I can try this.
Yes, it's regular USB, so.
I remember.
But with my fault.
Like that.
Right, I know. I know.
I'm just gonna go 1 second.
Reason, Caitlin, the 2 minutes behind was it took her a few minutes to muster up the will courage to go out into the cold.
It is
The willpower.
very heinous today. It is extra heinous today, I agree. Well, it's a pretty color, I'll give it that.
Oh.
Survey, I should have done. The next thing.
Well, so the HDMI makes it purple, which is an interesting choice that it's making.
Oh.
Let's try this one.
Tonight's event.
This is a little bit.
Is it like to share that way? Yeah, no. No.
Okay.
Okay.
Yeah.
And I'm waiting it for changing the pointer, like the laser pointer.
Okay, so which, this is the owl.
So this is the owl, yeah.
So let's put a, okay, then let's try
Yeah.
putting the owl in here.
For some reason, the HDMI cable didn't work on my computer, like the connection to the projector.
The thing that worries me is that my Mac is ancient and it loses battery very quickly, and if you take up both of my spots, I have no way to charge.
Do you want me to use my computer to?
No, it's okay. It'll hopefully last at all. I'm just gonna close basically everything that I can. But if I played this slideshow from start now. Okay. And if it's, magnifique, okay.
I'll email the thing again.
Yeah, it works. Cool. Um. Really said something in right there.
Zoom putting its brand on it.
Zoom is so, okay, there's no issue. I'm
We have
close.
the issue.
Oh, we have an issue. Okay, what is the issue?
The Zoom is not framing things correctly.
Look at the green window, it's only taking part of the screen. Maybe disconnect, go to the Zoom, go to disconnect screen and then we can.
Disconnect screen.
Now it's the full screen again, so it should burn now. Yeah, that's.
We do. That's it. Go on, do it. Number four. What's the point? I have a shot there, maybe. Oh, okay. And then I'll call it. No. Yeah, you did it. Yeah. That's my daughter.
Oh, nice to meet you.
I came from Toronto purposely for that. She told me I couldn't.
Wow, I feel so special.
You're back, man. Yeah. It's just. No, so that. I'm new this. With, you know, just.
Yeah.
And it's still. Yes. I thought probably. Okay. Good. Yeah. I don't know. It's like. Just forget it. Oh, I was thinking I was going far back. It's too deep. The guy who's the yeah, he's. Yeah. Running up. It's all. Yeah. I don't know. I'm waiting.
That video is not on. Why is the video not on?
Yeah, going to the Zoom thing.
I had to end this thing for now.
Perfect, and then meeting out. This. We see meeting out.
Meeting room is plugged in, I think.
No, it shouldn't.
Let me unplug it and replug it.
Turn this on.
Okay, here's what we're gonna do. I'm gonna unplug it from here. I just won't have a slide advance.
Oh, because it was,
Guys should be working. Yeah. Oh, yeah, just that's six. Yeah. Yeah.
Is it?
it is. So let's.
While you're doing that, let me put as many applications as possible.
Yeah, he did have.
Maybe at 2 minutes, so. Yeah. Sorry, is this, there's a $5 one?
Can I end the show for 1 second? Redo it? Right. Because I just plugged this in, will be super useful to be able to share the slides.
But what do you want to do?
See. It's fine, I'm not doing anything. Here, it is.
Okay, it works perfect, yeah.
You actually have. That involves.
Is it better now?
I won't do more time, like 10 minutes later. Okay.
That's so good.
Is there like a delay?
I always like,
like a minute.
Yeah.
Yeah.
Once more for the last name.
Sorry?
Do you need once more for the last name? Or you
I
good?
think Zagorac.
Yeah. very good. Thank you.
She's not good at all.
No, it's like people find it tricky.
So, hello everyone, welcome to the last public talk of this year. It's my pleasure tonight to welcome Luna Zagorac, who's a TSI postdoctoral fellow, and her talk, Digital Skies for Ancient Context, will go over how she investigated stellar data from Ramesside clocks. So we have like a beautiful blend between astronomy, astrophysics, computation, and as well as history, ancient Egyptian history. Before we go into the talk, I would like to welcome you to the TSI Physics Public Series, which most of you probably know. We want everyone to feel welcome during the talk. So if there's any issues and you feel uncomfortable or you want to reach out to us, we have some volunteers. There's me, there's some other volunteers, and you can reach out to us because we feel like we all want to feel welcome so that we all can make great physics. And yeah, if you ever have feedbacks, we love feedback. We always try to improve our physics talks and the communication with the audience. So if you have suggestions, please reach out to TSI outreach at physicsmcgill.ca. And with that, I'm leaving now space for Laura, and yeah, enjoy the talk.
Okay. Hi, everybody. Thank you for being here on this incredibly cold night.
I actually forgot there's the microphone.
There's a
I
microphone.
totally, yeah. So, yeah, there's a wireless microphone and yeah, that's true.
Okay.
I was so busy doing that.
How does this go?
Yeah, you can put it here on your neck.
Oh, on my neck. Okay,
yeah,
that's
just leave
much
it
more
there.
comfortable. Somebody told me that there's a party in this building for the undergrads and they're playing Sexy Back, which I guess is a throwback song at this point. So I guess it was in my Britney Spears, Justin Timberlake era and trying to put on the like headphone microphone. So yeah, everybody, thank you so much for braving this incredibly cold night to come and hear a little bit about the weirder corners of my work that I do here. So as mentioned, my name is Luna Zagorac. This is work that I am currently doing with Professor Sarah Simmons, who's another amazing Canada-based researcher at McMaster University and a proper Egyptologist. So I promise most of this is not wee-woo. So yeah, without further ado, let's get into it. Digital skies for ancient contexts using Python to investigate stellar data from Ramesside Star Clocks. So the first question that you might have on your mind, and I wouldn't blame you, is I am an astrophysicist, right? That's why McGill University hired me as a postdoc and pays me the big bucks. So what brings astrophysics and ancient Egyptian stellar data together, right? And the first answer is the word cosmology. In my daily life, I'm a cosmologist, and the word cosmology actually has a dual meaning that's very near and dear to my heart. So first of all, cosmology is a branch of physics that studies the origin, content, and evolution of the universe. You could say more or fewer things about them, and if you ask an astronomer and a physicist what it is, they might have a little bit of a fight about it, but that's sort of the general idea. But at the same time, it's also a way of making sense of our place in the scheme of things, as the philosopher Tolman wrote in 1985. So in some sense, cosmology is a really ancient human practice. It's about asking ourselves about the universe and our place within it and how to make order out of chaos and uncertainty. And this is the intersection where I really find inspiration for all of my work. And also the starting point is actually quite the same for all of these projects, which is that both my sort of cosmology hat in the sense of I think about what dark matter is and how it would change the universe around us, but also thinking about Egyptian stellar data, both start with a model and use it to tell a story with data, right? And so fundamentally, let's start from there, because fundamentally, what is a model? And so Merriam-Webster, I looked it up, has many definitions for this because it's a noun, it's a verb, it's, many things. But definition number 3 is a system of postulates, data, and inferences presented as a mathematical description of an entity or state of affairs, right? Also, a computer simulation, see simulation sense 3A, based on such a system, which really intrigued me because computer simulations are what I do both in this work and also in my day job as, a physicist. So I wasn't lazy. I went and looked up simulation sense 3A, which is the imitative representation of the functioning of one system or process by means of the functioning of another. So computer simulation of an industrial process, for instance. Also, an examination of a problem, often not subject to direct experimentation by means of a simulating device. So this is sort of maybe allows you to access those bits of like the cosmos or knowledge that you don't necessarily have access to otherwise. That being said, I would be remiss if I didn't highlight the other 2 definitions, the second of which is a sham object or counterfeit. Which brings me to, which, made me giggle, but also brings me to, I think, the most crucial thing about models, which Georgia A.P. Box, who is a statistician, once said, which is that all models are wrong, but some models are useful, right? So the goal here is to make a useful model, but also don't let it lie to you. Remember that it's wrong and know exactly where it might be wrong and by how much, which is good practice in general in science, data science or whatever. And the other thing about models is that we've been building models of the universe for a long time. Humans just really can't get enough of looking up at the sky. And so, for instance, this is an illustration of an Egyptian map of the cosmos. I won't be talking about this data in particular, but this is from a sarcophagus that is currently in the Met. A smaller version of it, just like a fraction of it, also exists at the Yale Peabody Museum in New Haven, Connecticut, but those are the only 2. But this is the idea of a sky goddess stretching over a god of the earth. Note that the sky is a woman and the earth is a man. That's unusual. There is a god of the air holding them up. And then in the center, you can see these circles where there are some references to sort of the earth. So like a map of the universe, a map of the earth, right? We can also think about planets on epicycles cycling the Earth, which was a Greek idea that, again, became popular in the Middle Ages, which is one of my favorite things, which is that when you get really, really tied, I think it illustrates that when you get really attached to an assumption in your model, in this case, that the Earth is in the center of the solar system, you have to do wackier and wackier things to match the data. But then when you accept that actually maybe the sun is at the center and maybe not every orbit is a circle and everything isn't, unfortunately, as pretty as we want it to be, then it all starts to make a little bit more sense. And finally, the current, what we call the concordance model of cosmology in physics, is the model of everything there is in the universe, which is mostly dark matter, dark energy, and only 5% ordinary matter. And my favorite thing about this nomenclature, as I've heard it, is that dark matter we call dark because we can't see it and we don't know what it is, and matter because it behaves just like ordinary matter, except not with light, we can't see it. And dark energy is dark because we have no idea what it is, and it's energy so that our colleagues to the south can ask the Department of Energy for funds, or they could before the current administration anyway. So we've been modeling systems for a very long time. We've always been looking up, and it's not really surprising because the sky is our window to the universe, right? The sky is how we get most of this wonderful data. When you look up at the sky, you can see wonderful things. You can see planets, you can see stars in our own galaxy, you can see newly formed stars, you can see clouds of gas, galaxies from 13 billion years ago, since James Webb went up there, right? Our own black hole and so much more, right? It really is how we get data. Without astronomy, without the sky, without being able to access the sky, we would have a very hard time I would have a very hard time convincing somebody to let me think of theories as explaining this if there was no data to begin with, right? And in another sense, we've looked up so long that the sky has become our heritage, right? So for instance, if you can think of Stonehenge, which is a really famous monument, it is famous because all of these celestial alignments that exist, right? It's not just a bunch of stones, it's a bunch of stones that tell a story and have a relationship to the sky in some sense like we do. And so this is not just me saying it, so spake it UNESCO back in 2005. So the sky, our common and universal heritage, is an integral part of the environment perceived by humanity. Humankind has always observed the sky either to interpret it or to understand the physical laws that govern it,
universe, right? So being a physicist and I don't know, thinking about maybe how humans interact with the sky isn't so different. And in this issue in particular, they talk about astronomy and world heritage, which is astronomical heritage or cultural heritage relating to the sky, recognizes the relationships between humanity and the cosmos, right? So this is a very, very long-standing thing for us as a species, both from a scientific perspective, but also from a heritage and cultural perspective. And those things aren't always really separable. So without any further ado, hoping to have convinced you, or at least told you an interesting story about why I live at the intersection of these seemingly disparate fields, let's go through an incomplete overview of Egyptian star data before talking about how I access some of it and how I try to tell a story about some of it. So as a quick intro, let's go through about 4,000 years of Egyptian history, no big deal. But these are some periods that modern Egyptologists like to think about. You'll note that they start in like 4300 BCE. And here I've only gone to the Roman and Byzantine Empire, which is from 30 BCE. Does anybody know what happened in 30 BC? Does anybody have like a historical figure they associate? Maybe there's like a snake and stuff. Cleopatra, yeah, totally. So this is only up to Cleopatra, right? And Egypt still exists and has always existed. And so there's much more to this story, but this is what we would call broadly pharaonic Egypt, let's say. And I've highlighted 3 periods here because they're maybe the most famous, which we call the Old Kingdom, the Middle Kingdom, and the New Kingdom. And so the Old Kingdom, if you think about, if you associate anything with the Old Kingdom, you probably associate the pyramids, right? This was a time of great building of pyramids, including the 3 pyramids of Giza shown here. And so that's a real emblem of Egyptian culture and history. The Middle Kingdom is less well known in pop culture. It isn't always referenced in pop culture, but it was a real golden age in Egyptian history. When you're a precocious physics graduate student and you sneak off to take a bunch of classes on how to read hieroglyphs, they actually teach you Middle Egyptian, which was popularized during this time. And a lot of later sort of like literature and buildings and stuff like that harken back to this golden period. And also they had a bunch of pharaohs called Senwosret that liked to represent themselves like this. It was a very distinct style. And I just like him. I think he's cute, especially because he looks so tired and he has these huge ears. And it was meant to represent that kingship is a burden and he's really bearing it. So I think that's sweet. And then finally, the New Kingdom is pretty famous in pop culture. So the Golden Mask of Tutankhamun, the pharaoh Tutankhamun lived around this time. And so that's very famous. The pharaoh Ramses II, who is sometimes referred to as the pharaoh of Exodus, also lived around this time, but was also a big military leader and lived to 90-something years, which was basically unheard of at the time, reigned for something like 67 or 68 of them, and in fact had the first peace treaty under his rule that we've ever had written down, that we've ever found. So those are just a few snippets of Egyptian history. Those are a few terms that I will be using. So the Old Kingdom, the Middle Kingdom, and the New Kingdom, with an emphasis on the Middle and the New Kingdom. At the same time, let's talk a little bit about geography. So Egypt is often said to be the gift of the Nile, and in some sense it really is, because this narrow valley is incredibly verdant. It's incredibly fertile because of all of the silt that the Nile brings from further down south, which is called the Upper Nile, whereas the Lower Nile is up here. That's why this is Lower Egypt and this is Upper Egypt. If you know how directions work in Montreal, you won't be surprised by this. So hopefully that's okay. But in terms of some of the things that I'll be mentioning, we'll be sort of around here in the middle of this picture near Thebes, or modern day Luxor, if you've heard of it or if you've visited or anything like that. So this was the capital during the Middle and the New Kingdom. And so a lot of stuff was happening here. This is also where we have the Valley of the Kings and the big temple of Queen Hatshepsut, if you've ever seen these. So today we have two big temples here on the eastern bank, which is Luxor and Karnak. And then on the western bank, this is all desert. And these are all tombs built into the rock and dug into the rock, including the Valley of the Kings, where many of the kings that we'll be referencing are buried. Secondarily, I'll mention the Abydos Temple, which is slightly to the north, but was really, really important. It was dedicated to the god Osiris, who was kind of the god of kinship and the resurrection. He was the first ever mummy in Egyptian mythos, and so you can imagine why that's really, really important. I'll also mention Asut up here as a site where a lot of this data has been found. And I think that's about for what I have marked. I might quickly mention Aswan here down south, but to a lesser extent. Okay, so now that we have some sense of time and of geography, let me present the three types of Egyptian data that I'll mention today, and then we'll get into one of them in more detail. And these were sort of from the Middle Kingdom to the New Kingdom, with room for this intermediate period in the middle, where I got a little confused about who was ruling, which is why it's called the intermediate period. So first of all, there are these things called diagonal star tables that look a little bit like this. They are also sometimes called diagonal star clocks, though this is falling out of favor because it's not really clear that they're a clock. But it's pretty clear that they're a table. And they're mostly found in coffins, and not royal ones, sort of coffins of, the nouveau riche of the time, if you will, which is pretty interesting. And they date to about 2000 BCE, right? But the latest version that we have is from almost a millennium later and is on the ceiling of a newer addition to that temple of Osiris that I mentioned that was really important, the Osirion. And so that's from around 1200 BCE. Around the same time, we have what's called sometimes the transit star clock, though it's more commonly now called the Book of Nut, again, because it's not clear that it's a clock, which is this vignette of the sky goddess stretching over the earth, with the god of the air holding her up, swallowing the sun in the evening and giving birth to it in the morning, which was sort of the story of what happened to the stars. Where were the stars during the daytime, right? They were inside of their mother's body only to be reborn. It was a cycle of death and rebirth. The Egyptians loved their cycles of death and rebirth. They saw it every day, and they recreated it in all of their stories. And there's a lot of text here, which is interesting and references these diagonal star clocks that again also appear here at the Osirion. But again, this is almost 1,000 years later. That's a big gap. That doesn't mean that they weren't used in the meantime, but we have no evidence. And finally, the thing that we'll talk about a little bit about later is these Ramesside Star Clocks that are the youngest of the three. They start appearing in the Valley of the Kings around 1150 BCE. And they look very, very different, but we'll get into them. I will also mention that these two seem, from the investigations that people have done, to talk about like an idealized sky, a sky that's more, let's say, religious or symbolic than a realistic sky that I'm taking observations of and saying what happens every night, which is another reason why the Ramesside Star Clocks are where I start with sort of trying to recreate some of these observational techniques. Okay, so diagonal star tables. So here's one picture of them, and you can see that they're indeed a table. That's kind of what fascinates me about a lot of this data, is that in addition to observing the sky and communicating with nature, man has always made tables. Apparently, we have a need to stare at Excel for some reason. I guess it's a pathology. But in any case, so these are mainly found in coffin lids from the Middle Kingdom. They're mostly from Asyut, so just a little bit north of Luxor, right, that capital at the time. But there are a few from Jebel Thebes, and Aswan as well. So they weren't unique to that place, but most were found in that place. And that could be a function of the fact that they just happened to survive there a little bit better, but we don't know. They're divided into what's called K tables and T tables based on the first star. So there's two families of them, if you like, but they show the same data. These stars are sometimes called decans by the fact that they think that there's an idea that they change every 10 days. And they probably do have some observational basis. They're probably not out of nowhere, but they are quite idealized. And so to see that, let's look at half of a coffin just sort of drawn, because it's easier than on a picture. So the coffin would continue this way to fully show. What we have here is 12 rows that we think represent the hours of the night. Far as we can tell, the Egyptians were the first one to ever come up with the idea of the hour, and it first only applied to the night. Only later did it start applying to the day. And so the 12 hours of the night are sort of an Egyptian standard. On the other hand, in the columns, we have weeks. There are 36 weeks represented here. So 36 times 10 days, if each represents 10 days, which was their week, is about 360 days. That's about a year. Yeah.
Were the hours by the Egyptian like consistent, or were they like dependent on the nighttime of each day?
That's a great question. We think they depended on the time of the year. We think an hour is the thing that is 1/12 of the night, not a thing that is 60 minutes or 40 minutes or some constant amount of time. But I'll talk a little bit more about that later, but that's a great question. Right, so if this went all the way, you would find 36 weeks, 36 times 10, which is the length of an Egyptian week, 360 days, about a year, right? And secondarily, if you looked at the hieroglyphic texts here in the middle, you could read some information here. So for instance, you could read that this coffin belonged to a woman called Ashit, and she was a high priestess. And you could also see here in this sort of like ribbon, I guess, some stars and constellations that we kind of know. So Sopdet, we believe, was their name for Sirius. And Sah was their name for Orion, vaguely unclear exactly what part of Orion. And they were important because they had sort of correlations in the religious pantheon. But, oh, and this one, the foreleg, can anybody guess what constellation this is? Everybody murmured, somebody say it loudly.
Ursa Major.
Ursa Major, yeah, it's the Big Dipper. And finally, we have Nut, which is the sky goddess, so just the representation of the whole sky. And far as we know, these are the only 3 constellations that we have kind of an idea of what their constellations corresponded to in the Greco-Roman sky that we still use. Otherwise, we have no idea. So if you look anywhere in this table and you follow, let's say, this name, which is a star, right? You can see that it travels diagonally, these 2 lines across. So that's why they're called diagonal star tables. So it looks at this star, whatever it is called and whatever that means, and it's always something like he who is in the boat, which is a lovely name, but doesn't tell me where in the sky it is, right? Because I don't know, I don't have that system. And so in week 1, it is in the 9th hour, in week 2, it is in the 8th hour, in week 3, it is in the 7th hour, and so on and so forth, hence diagonal star clocks. And there have been some attempts to sort of identify these or try to make a working star clock out of them, but thus far mostly have failed. They behave more perfectly than our sky behaves. They're the little epicycles where you really want things to be circles, and then you have to keep adding epicycles to, you know, get retrograde motion of Mars or something like that, instead of just accepting that it's an ellipse. So there might be a way to crack it yet, but thus far it seems a little bit too neat to be the sky that we know and love completely. So secondarily, this is the Book of Nut. So this is the one that appears later. Oh, and the original title, and this was quite a coup when this was found, is The Fundamentals of the Course of Stars, which I think is quite beautiful. But so this is a text that looks a little bit something like this. It's sort of more illustrative, right? And so this is found a little bit later at this Osirian at Abydos, about 1200 BC. So again, about 1,000 years after the previous. And then a few other places, but that is sort of the earliest that it is attested. And so the text there's a part of the text that is a dramatic text that talks about the goddess of the sky, of the god of the earth getting into a fight because she kept eating their children, which is rude, I guess. But also it discusses various astronomical phenomena, including the movements of the decans, these stars that move every 10 days in the diagonal star clocks. And so it seems likely that it has some progenitor text. Somewhere there's like a papyrus or, you know, a remnant of a papyrus that told the same story, and it was only, you know, put into stone so that we can find it later. And so in some sense, it has this important religious text, but it also has the closest thing we have to a how-to on how to interpret the diagonal star clocks. So clearly there's a link here, but there's 1,000 years of history missing, which is a little bit heartbreaking and also very, very cool. And so, yeah, to just get a sense of what that looks like, the drawing from the Osirian is a little bit like this. So here in the part 1, you know, around the front and the back of the goddess, we have the actions of the sun god, the actions of the deities, also the actions of the decans, and the daily course of the sun and the topography of the sky, as they understood it sort of religiously. And here in between, we have, you know, them arguing about infanticide, I guess. Right, and so in terms of what they tell us about these decans, about what these stars are doing, they do things in a specific order. They are first, then they spend 90 days in the west, they spend 70 days enclosed by the duat or the afterlife, they are born, they spend 80 days in the east, and then they spend 120 days. So the best interpretation of this that we have is that when they are in the duat or the underworld, they are invisible, right? That is the part of the year that you can't see a certain star. Because it just, anytime that it rises, it's during the day, so you never get to see it in the nighttime, or in other words, it is inside of its mother's body, right? Then it is born because she gives birth to the stars after she eats them. It spends 80 days in the east, and then 120 days working is probably where it's high enough to do whatever it was meant to do, be a clock or not be a clock, or be a calendar or something. And 120 days is, you know, 10 days times the 12 hours. So that's as many instances that it was having the diagonal star clock. And it seems like a coherent picture, and it seems like it should work, but it doesn't work as nicely as we would like it in terms of like being a practical timekeeping device. Hence why we think it's maybe a bit of an idealized sky. Maybe it's more about the other life than this life in particular. And finally, my favorite, because I'll be talking to you about them a lot, are the Ramesside Star Clocks, or really the Ramesside Star Clock, because there's only one version multiplied a few times. And this is a photo from one of the tombs by my collaborator, Professor Sarah Simmons. So they are found in 3 tombs belonging to 2 pharaohs. These are Ramses VI, Ramses IX, and the one that Ramses V and the 6th had to share, poor dears, because one of them died a little bit too early, so they just kind of had to stuff him somewhere, and that's where he got stuffed. But that does mean we have 2 instances of the text, which is nice for us. So each instance of the text has 24 of these little tables, each spanning 15 days now, not 10, so there was some sort of change here. 24 times 15 is still 360 days, so that's pretty good, especially since by the Egyptian calendar, they were 360 plus 5 days. The plus 5 days were called epigomenal days, or days upon the year. They were the days when the spirits are alive and there was bad juju and you really had to protect yourself from it. And the way that you did that is you got drunk and you partied in the street, which is a brilliant idea. So yeah, these epigomenal days aren't explicitly mentioned, but maybe they're included in the last table. That's not quite clear. And this presence of this human figure maybe suggests more observational origins. So let's do a little quiz. So look at this human figure. Is there something about this figure that is different than the way you see Egyptian art, including in like comics or, yeah. His eyes are looking at you, right? So the one thing you know about Egyptian art is that generally they're looking to the side. Generally, it's a profile. And the reason they did that was to show the maximum of the human figure, because that likeness had to live into the next world. But he's looking at us. And that's not unheard of, but it is rare. And it's a specific choice to make for the specific text that appears flash in the pan amongst these 4 pharaohs and then never again, as far as we can tell. That's interesting. And so if they do indeed have observational origins, if he's looking at us for a purpose, then that means that this is a great start to maybe reconstructing the timekeeping model, right? Because maybe it is actually observational data or a little bit less idealized observational data. And now let's do the same thing. So this is the format that they take. So they always have a little dude sitting under again, an Excel sheet, because I guess that's a human need. And next to these hieroglyphic inscriptions telling us a little bit something about this data. So this tells us the name of the asterism. So whether it's a single star or a constellation, hard to tell, but it's always something star-like, right? And it also starts with the first day of the month of Achet, or the 15th day of the month of whatever. So it tells you what month it is, what season it is, and stuff like that. So you know how to order them. Also, it has 12 hours, but you'll notice that it starts with a 0. As a computationalist, I love this because I think indexing from 0 is the right way to go. But the reason for this is because the first row tells us the beginning of the night, and then the first row is the end of the first hour, the second row is the end of the second hour, et cetera, et cetera. So it goes from the beginning of the night to the end of the 12th hour, which is equivalent to the end of the night. They also have these 7 positions that are possible for each of the stars that are relative to this human figure. So he is looking at us for a purpose, it seems like. And those positions are written in hieroglyphs here, or rather transliteration of hieroglyphs here, but they are relative to the human, right? So they are upon the heart or in the center. They are above each of the eyes, each of the ears, or each of the shoulders. One thing to appreciate here is that I have chosen the translation left and right. These equivalently mean east and west, and we don't know which one they mean, or if they mean both. So, okay, that's a funky little guy, and there's some data there, and I would love to do some investigations. Where do I start? And I start with Python, with doing a computational model, because that's what I do. And so here's the idea. Once upon a time, there was an Egyptian observer who observed the night sky and saw the night sky as it looked then. This is important asterisk we'll come back to. And then using some method, some decision, he chose where to look, he chose, or she, they, I don't know. They chose what stars to write down. They chose how high they had to be or how clear they had to be, or what days of the month to observe or something like that. And they wrote some astronomical records, right? And so what we're really after is this method. What is the method that they used? And can we see the statistical traces of that method? Because if we can, then maybe we can say something about the data itself. And the way that I do that is first I reconstruct the sky as it looked back then. I use a module that I wrote that is based on AstroPy, which is what many astronomers use in their day-to-day research. So it's really, really helpful. And we can algorithmically create synthetic Ramesside star clocks and compare them with the primary sources, by which I mean I will make a bunch of assumptions, controlled assumptions about the model. I will tell my code to make me Ramesside star clocks based on that assumption. I will produce them, and then I will compare them to the original and see if the statistics match. And this is, this is a tried and true way of doing science, and it's really, really fun when your sources are hieroglyphs and also when they aren't. So we have the data, we have the ability to precisely model the sky. So the missing component is this method, and it's not a simple problem. There's many decisions that could be made here. And also every decision that I can think of is in some way impacted by the way that I'm used to thinking about the sky, which is not necessarily how they thought about the sky. But so Sarah and I wrote the first of what we hope will be a series of papers and thought about each of these factors and what we can say about them and tried to divide them into 3 groups vaguely. So factors that we can reasonably assume, like when the observations were done and where they were done, without making this assumption, we really can't get anywhere. So we kind of have to, but also we have some good arguments for doing so. There are some factors that we can test. For instance, were they looking east or west or south or southwest when they were doing these observations? And then there are some human factors which are quite ineffable and that we can't test for even in principle, but that may very well impact us. So this is where knowing where your model is no longer real or where your model will fail you is useful. So let's start with the reasonable assumptions. These are the when and the where. So first off, the date of data collection. And the reason this matters is because the Earth has a tilt. That's why we're all freezing right now, right? But also this tilt wobbles. It's called the precession of the equinoxes. So it's an accident that we live at a time where the North Pole is pointing at Polaris. If we lived around 3,000 years ago when these things were first written down, or at least the first time we saw them written down, we wouldn't have a North Star. So the sky looked different, it shifted. And so this is one of the things that my module had to add to AstroPy because most astronomers weren't thinking about what happened 3,000 years ago. They're happening about what happened, what is happening in the sky right now, if they're looking for like the positions of the stars and stuff like that. So the first attestation that we have is actually a little bit earlier than I told you, because they looked at my friend's Egyptology PhD thesis and I found this little drawing. Look at this guy. Does this look like a Ramesside Star Clock to you? It does to me. And this is a little bit earlier than the earliest full one that we have. So this is just a plan for a tomb based on a papyrus, which is, as you can tell, is kind of falling apart. It was never implemented, but they thought about it, so it existed. So the latest date that they could have existed is 1150 BCE or so. We have chosen a date of 1300 BC based on our previous understandings, because that's around the time that a special astronomical occurrence happened, which is when the civil year started at the same time that Sirius rose flag blue. Meaning that it rose with the sun in the morning. So it was basically July 1st was a good date in that year because their year kind of wandered because they didn't have leap years. In any case, the exact assumption here shouldn't matter too much because kind of 500, 600 years plus or minus, the sky would not have changed that much. So that is our first assumption. The place of observation, meaning the latitude, is important. You see a different sky, and that can only be Luxor, or it only makes sense for us to assume Luxor. Not only because that's where these things are found, and that was like a real center of activity at the time, but also because it's kind of in the middle of Egypt, right? So if I'm wrong, that is kind of like my average assumption. It's less wrong than going into either of the extremes. And yeah, so the reason that matters is because it'll change the sky that I see. The situation of observations, where were they done? We're going to assume on a temple rooftop with clear horizons. How clear your horizons can be as in a desert is sometimes kind of questionable, especially in a city. They didn't have the type of light pollution that we had, but probably some. The time of starting or ending observations, when did the night start and when does the night end? And this is not a thing that has one answer even today, right? There are 3 twilights that are well defined, for instance, and those are civil twilight. Well, this is dawn, but whatever. Civil twilight or dawn, if you like, when the sun is 6 degrees below the horizon, nautical twilight, which is 12 degrees below, and astronomical twilight, which is 18 degrees below. So just to be safe, we chose nautical twilight of -12 degrees sort of in the center, but this is another thing that impacts, for instance, the length of each of the hours, right? And yeah, so timing the hours, we assume that the hours are equal length. We assume that every night was divided in 12, and so the length of an hour in the summer would be much shorter than the length of an hour in the winter. And this isn't totally wild to assume, actually, because there is something called the Carnac water clock, which was basically a jug that was made in a certain shape that you poured water in at the beginning of the night and it leaked water. And when you looked at what the water level was during the night, there were like little divots that told you what the hour was. And they were made so that the hours weren't equal. So there's at least one good piece of archaeological material evidence that says this. And also Sarah did this experiment in her bathtub in 2000 and found that it is indeed correct. So yeah, that's our assumptions. The testable factors are the variables of our model, right? So this is the interesting thing, like what is the directional observations? What are the positions? Like how wide is this horizon, right? Because if you're really far from me, I'm gonna pick on you because you're right here and you're useful. So if I'm really far from you, my horizon is really narrow. But if I get really in your face, then suddenly I'm seeing a much wider horizon. And if I divide that in 7, I will see a different thing, right? Also, are there gaps between these bins? This is an interesting question because you'll notice that when we're looking at the rows, the star that indicates the position is sort of in the middle of this line. But when it comes to the positions, it's right on the line. It's not in between, right? It's on the line. So is this some level of precision that was really important? Maybe, maybe not. But so maybe there were gaps between the bins. Maybe one needed to be really precisely above somebody's eye. How high do we want to look for stars? At what point are they no longer useful? Because it's really easy to tell where something has risen when it's just above the horizon. But on the other hand, horizons are tricky. There's dust, there's light, there's stuff going on, so it's harder to see. But then if you rise really high, then it's harder to tell where exactly you rose from, assuming that we're even looking for risings. We were not. Also, the star names. So instead of making assumptions about these individual stars, so for instance, I told you that Sopdet was Sirius, we're not relying on that assumption at all. What we are doing is we're testing the entire data set statistically, looking for the method without assuming anything about the stars, just in case there are some red herrings here, and also to be complementary with previous work. Because while Sirius used to be called Sopdet, that's it, now it's called Saba and Sopdet, the star of Sirius. Is the star of Sirius different than Sirius? Is it just how language evolved? We don't really know. And so we don't want to make any assumptions about that. And so here are some examples, right? If I create a night sky, and I'm looking right at twilight, right as the night is starting, if I'm looking west, what I'm seeing is a pretty bright sky. If I look south, I'm seeing stars that are moving side to side and also in a less bright sky. And then when I look east, I see stars that are rising and also a much darker sky. So it changes the conditions, right? On the other hand, depending on if I just assume that I'm looking south or something like that, if I assume how wide my bins are, if you like, they can be equal of some width. They can be accelerating. Maybe the central one is really narrow because we see a lot of data in the central one, and maybe the other ones are wide or vice versa. And maybe there are these gaps, right? Maybe you need a real different level of precision. And so this is just a cartoon I made with basically the same 3 stars everywhere, but depending on the decisions you make, you have a different choice of stars to make here. Like you don't have all of the options always available to you. So this is just an idea of how we do the testing. And finally, there are these human factors that aren't testable even in principle. So physical, human, and equipment factors. How well could they see? Was their eyesight good? Were they old? Were they tired? Were they drunk? Also human and psychological factors that overall intent, why were they doing this? Were they doing this just because it was fashionable to be into astronomy around that time and they wanted to make pretty things to put on tomb walls? I kind of doubt it, but I also don't know. Were they making them so that you can meet your mate down by the pub at the correct hour because you saw, Rigel rise or something like that? I don't know, maybe. We can't know how dedicated, tired, or careful they were. And so I use this, this is my only Egyptology joke, I promise, but sort of on the scale from the Senusr III, who looks tired on purpose because kinship is hard, to Thutmose III, who really like to look young and strapping. How tired are you today? How well are you observing the night sky? And anybody who's been a student knows that, one day you're Thutmose, one day you're Senusr. What can you do? But maybe your statistical approach can see something not about any single one of these factors, but about all these factors taken together in that. So let's think about it. Our testing algorithm is to calculate all of the start positions for some year, given our factors 1 through 5, so the things that we can safely assume. We have some algorithm to make different Ramesside star clocks based on the factors that we can test. And that produces synthetic Ramesside star clocks in Excel because the children yearn for Excel. And so we have some, synthetic Ramesside star clocks that we can compare to the real. And we can do this statistically because remember there are 24 tables and there are 4 iterations of each. So we have a pretty good handle on things like copying mistakes, which are common, right? Because if you're a scribe making a bunch of these tombs all the time and you're tired and you're sort of like, doing things in stone, you make a mistake sometimes. So we can think about these heuristics, like what number of unique stars are used? In the real data set, it's 47. What are the relative numbers of each position? So in the real data set, we really see the 0 position dominate. So this already doesn't look like a good choice to me. On the other hand, if we look at the human factors, maybe we can also do something about them. So in addition to taking the real sky with like the stars that we know and love and just winding the clock back on them, I can also create a sky populated with random stars that are just statistically arranged in much the same way that our stars are, but they don't have names that I know. I don't have opinions about them. I'm not likely to choose something that has Sirius in it because I like Sirius and it's bright and associated as like a significant star, right? And so in some sense, what I'm doing here is I'm preserving the statistics inherent to the night sky. And if running the same algorithm on 2 of these skies produces different results, then maybe some of that gap can be explained by some human ineffable factors, which is not saying about any of them individually, but maybe bring me one step closer. And so can we differentiate the properties which are due purely to statistics of the night sky and those which are less likely due to human choice is the question here. And I don't have any answers for you because that paper is still being written, but I hope to have answers for you really, really soon. But as a quick wrap up, let's turn back the clock. So modeling ancient observational practices. So there is a wealth of data from astronomical data from ancient Egypt, and the observational method is still unknown. I also picked and chose 3 specific types that were all before the Babylonians and the Romans came because I wanted sort of like quote unquote purely Egyptian influence. But there's many more. The zodiac of Dendera, for instance, is a really famous example that I didn't mention at all. And modeling the method instead of the stars themselves and trying to identify them is really complementary work with stuff being done, including from like linguists that have a better sense of how these names were constructed and how they were used and how referring to them evolved over the millennia. Using the statistics of the data set is a new approach and it's powered by AstroPy. And yeah, we submitted our first iteration of this to the Journal for the History of Astronomy, and the part 2 with the gory statistics is indeed in prep. And just in case you can't get enough of Egyptian astronomy, I will say that my collaborator, Sarah Simmons, has a bunch of these videos on YouTube, and they're really, really good. So for instance, this one is for the Toronto Centre, Royal Astronomical Society of Canada. It talks a little bit more about them, so I'll give that shout out. And finally, I'll end with my thoughts on the radical interdisciplinarity of the sky, because radical interdisciplinarity is really what I consider my work to be. That's why I started with telling you all of those intersections, and how I see this work is much the same as, for instance, doing tests of different dark matter particles. So the very word cosmology, I already talked a little bit about that, is an intersection. It's the utility of modeling across disciplines to tell a story with data, because no matter what we do, no matter how much math it is, we are always telling a story, whether to ourselves or others, right? And it's important to know that, I think, and be aware of that. And finally, I think it's important to think about the protection of astronomy and heritage at the same time. Like I said, UNESCO said it better than me, the sky itself is World Heritage. But also the sky itself is heritage in danger, right? For instance, due to light pollution that has become very, very common in our lives. And I just really wanted to shout out that we have a great privilege here to be living very close to an international dark sky reserve in Mont Magentic. And I encourage you all to look at what they're doing and really appreciate the fact that so close to this big city, there is still a place that you can go and connect to the sky and have it be your window to the universe, because many people in the world don't have that. And yeah, with that, I will thank you for your attention. Here are some things that I read. If you want to read more, some of them are in different languages. And yeah, questions?
Thanks. Thank you very much for the talk. So it sounds like you are trying to unlock a wealth of information here, kind of like a star Rosetta Stone, is what I was.
That would be great. I would
Yeah.
love that. Yes.
So I'm wondering, I don't know how far you are into it, but supernova, would they be reporting those in their charts? And that would be very interesting because it's a useful tool for dating.
For dating, yeah.
Yeah.
Yeah, so funny you should say that. Along with Sarah, there are two other people working on archaeoastronomy around the world, and we have our little like book/journal club every so often. And in 2 weeks, we're talking about a new paper about a supernova from ancient Egypt. So there is some data. I can't tell you a lot about it now, but if you found me in 2 weeks, I will be able to.
Thank you.
They knew about planets back then.
Yes, I did.
They should be pretty identifiable.
They are, yes. They separated planets from stars. They didn't
So can you
represent
not
them.
then correlate the two? If you know where the planets would be.
So they're not represented in these texts specifically. So there is mention of planets alongside stars, but they are always shown differently. They're shown as deities in boats because it was clear that they traveled the sky in a different way than the stars did. So they absolutely knew that it was a separate thing, but they don't seem to track them in the same data science way. They don't have the same Excel file. Otherwise, yes, that would be super useful.
Could the same thing be said about the lunar cycles as well?
So I know less about this. There is some tracking of lunar cycles specifically for calendars. Their calendrics were kind of a mess because there was like a civil calendar, which was, much like our calendar, except 365 days. So it sort of wandered around a lot. So I guess what the Julian calendar is now. There was the agricultural calendar, which is when the flooding happened, which was the most important thing. There were basically 3 seasons. The flooding, the reaping, and the sowing. And so those also, and there was a third calendar that was a lunar calendar that I know less about and I think is used less. There are some references to it, but not as many as it's been, or at least I haven't found as many because I thought being that my name is Lou. Great. Other questions?
I suppose this time period you're dealing with is out of well, prior to anything from India, China, and Japan. I'm very curious to know if there's any kind of matching in perhaps a later period of Egyptian history.
Good question. I don't know about those 3 cultures specifically, so I would hesitate to say anything. I know that later their Babylonian influence comes in through later incursion. Basically, as the New Kingdom ends, we see a lot of foreign influence coming in with indeed foreign rulers that take over Egypt. And so Babylonian astronomy comes in, quickly followed by Greek astronomy, and that's when you start getting things in terms of 60s and
In terms of
60s, right? Because the 60 minutes comes from more of a Babylonian system, and you start getting the zodiac, which is very non-Egyptian. So for instance, if you looked at these, so the zodiac of Dendera, which the French so helpfully stole and put in the Louvre, but thankfully the Louvre thieves didn't steal, for instance, has the zodiac that we are used to, right? And it has some mention of these decans, for instance, but not as many. It seems that they're mostly supplanted at that point by foreign influence. They do get mentioned a lot. There is some text that talks about the 42 decans as demons that Solomon has to banish later in early Christianity, which is really fascinating. So they seem to eke their way through. But yeah, Babylonian and Greco-Roman influence sort of supplants it pretty quickly. But I don't know anything about India, China, and Japan, and so I don't want to speculate on the spot.
so if I could just add, are you interested in the possible differences in the conception, let's say, of Babylonian or his Christian conceptions of what it's all about? Is that part of your interest?
I guess that's not what I spoke about in this work, but it's certainly part of my interest. I think that comes from, I don't know, it comes from my earlier statement that cosmology, the science is somewhat no matter how hard you try, it is always somewhat inseparable from cosmology, our sense of sort of like where we place ourselves as the observer. So if you like a preferred reference frame or something like that in physics speak. So I'm certainly interested. I just haven't said a lot about it in this talk.
So it's not fair to ask you if you have given any kind of glimpse of a difference of conception between, say, Christian or Babylonian and Egypt, or even different conceptions within the Egyptian history. So-
Conceptions
so
in
my
terms
thought-
of like the topology of the universe or how it was created or anything like that?
Yes, anything like that.
Yeah, I think the Egyptians had what we in modern parlance might call a bounce cosmology. For them, there was no end of the universe because the universe ended every day and was reborn every day. They really had this eternal cycle of birth and rebirth. And in fact, there were two words for time in ancient Egypt. There was linear time, which is called jet, which always goes forward, which is how we think of time. But there was also something called nehir, which is circular time. So every year comes again, every day comes again, every night comes again, et cetera, et cetera. And so I think there was an idea of a beginning, but there was never an idea of an end. And I find that, or like rather the end happened every day, and so it wasn't scary and there was no final end. And it was always a fight between order and chaos. In fact, the universe came from chaos, from a primordial soup, if you will, and was always sort of balancing between those two forces. So I guess I find that somewhat different than the idea of a specific creation of the earth and the idea, or the universe rather, and the idea of an eventual end, which they just kind of didn't have, as far as we can tell. So for instance, that's one, this is a wider question, but that's one difference that I think stands out to me. The idea of the two times I find very, very helpful and very beautiful.
And unique perhaps to Egypt.
I haven't been everywhere, so I can't say that it's unique, but I would say that it's definitively Egyptian. It is not just a throwaway comment, it is born through their entire religion, culture, and approach, far as we can tell.
Thank you.
Yeah.
This is a less scientific question, but I find it really interesting how you take cosmology and history and kind of mesh them together into this subfield. You called it astroarchaeology?
Archaeoastronomy is a word that other people have coined, so I just go with that. Yeah.
Okay, that's really cool. But I guess I was just curious about what led you to be interested in this archaeoastronomy.
Good. I'm sorry, this question doesn't have a great answer. I've always wanted to be an archaeologist. That's the thing that I wanted to do since I was little. I wanted to be an Egyptologist. I also wanted the ability to afford food. So, which doesn't explain my path. So sometime, I am originally from Belgrade, Serbia. I did my undergraduate education in the United States. I mostly wanted to go to the United States because you could double major. So I swore that I would do a major in archaeology and a major in some mathy thing that I could leverage for money one day. And I really hated physics up until that point, and I sort of did physics against my better judgment, and that's where I fell in love with physics. And I also just happened to be so lucky that I went to Colgate University, yes, like the toothpaste, which is a place that most of you have probably never heard, but happens to host one of the people that coined the term archaeoastronomy. So it's one of those things where in retrospect, you can sort of connect a really beautiful line and say that all of these dots were always meant to represent a butterfly or something like that. But the sincere idea is that I had no idea what I was doing at any point. I was just following my nose. And if I do one thing for too long, I get a sense of like, I don't know, claustrophobia. And so I like switching between these topics, and I like finding the thing that is similar within what is different and what is different within what is similar.
Have you been to Egypt?
But so many times. I lived in Cairo for about 6 months. I was on an archaeological excavation near Luxor. They sent us home one day because it hit 50 degrees Celsius at 11 a.m. Maybe you first, because you've already asked.
Okay.
Yeah.
You briefly mentioned that, so like the reason why they were drawing this star, do you think it comes more from like a practical way of doing, like
like the way we draw like routine maps of like the Earth, and, like for navigation and stuff like that? Or do
Can we
you think
hear
it
the
was that
question?
deeper
Yeah, so the
philosophical?
So the question is, do I think that the way that they drew and represented the stars is from like the same way that we would map the sky, say, or is it more like of a deeper philosophical thing? And I don't think they knew the difference. I don't think they ever tried to tell the difference. And so I think that's what makes this question tricky, because I showed you 3 things that could be data sets to work with, but the first 2 are kind of finicky and nobody's had much success with them, which is why I'm working with the 3rd one. And so to my mind, the 3rd one, I think, is probably a little bit more scientific, data science-y, proper, easy to work with, ordered, whatever you want to call it. But I don't think that, I mean, this is speculation. I don't know what they thought, but I really don't think that they made that distinction. I think to them it was all part of creation. And so I think that putting those stars and very precisely cataloging them very precisely on the line tells me a level of precision that I would call science, or at least data gathering, right? But I also think that it's embedded within a wider context and within this whole like program of decoration that happened in a tomb. And a tomb was basically just a recreation of the cosmos so that the pharaoh can live again, or the deceased can live again. So I think it's very hard to separate one from the other to some extent. But for all I know, they were just like a bunch of like fridge tossers that were like, that looks pretty, put it on the wall. I don't know. Sorry, you had a question.
And just again, is there any indication of brightness of these stars?
No, they don't have like a magnitude system or anything like that.
Or they don't talk about the one that's easiest to see or something?
No. So that is a good question, because these are parts of sort of like, this is part of like the decision algorithm that has to be made, which is a lot of the time, if I choose, you know, a good direction to look at and like a sufficiently wide horizon that I'm subdividing, I actually am spoiled for choice, right? I have more than one star to choose from. And so how do I choose? Do I choose the one that has a religious connotation? Do I always choose the brightest one? Do I choose the one that has appeared in the table before? Do I have a secret favorite and so I choose it? I don't know. And so we have a few choice algorithms that we are testing, for instance, to see if they can tell us any, I don't know, statistical trend in the data that maybe matches better or worse. But I think there's a level below which we'll never, right? But I think it's reasonable to assume that they want bright stars, because you don't want a dim little guy that you have to look for to tell you to go meet your mate down at the pub or whatever this is, right? Yeah.
Kind of along that same branch, did you consider color of stars? Like,
No. I mean, it's naked eye astronomy, right? And you can tell the color of stars with naked eye astronomy to an extent. But I don't know, it's hard for me to imagine that that's like your go-to. You know, if you were, I don't know, if we're both looking at the same patch of sky and you don't have one of those, you know, green lasers that you can't shine in planes, if you have to like tell me where to look, I think you could tell me look at the bluer one. I don't know, that would be my first instinct for how to identify one. Maybe it was theirs, but I think that there is less variation in that than in something like brightness, or like belonging to a constellation or something. But that is a thing to track for sure.
You mentioned earlier that a lot of these tombs were ways of like accurately trying to recreate the world. For the next slide.
Not accurately, symbolically.
Symbolically.
Right. Which is why nobody ever had pimples in their portraits.
Right. Are there other examples of like potentially scientific method driven recreations in the tombs that could help guide you methodologically?
Not off the top of my head. I think the other, let's say, the other thing that screams scientific methods to me in the canon is in the Temple of Hatshepsut, which is quite close to the Valley of the Kings, actually. So she was the woman pharaoh. It's a whole thing. There's many books written about it. Look her up if you haven't. She's really interesting, and the period around her is really interesting. But she is famous for sending an expedition to a land called Punt, which was a very important trading partner for Egypt. It is where they got their resin and incense from, which was incredibly important because it was part of these rituals that happened in temples and stuff like that. And it was a very rich land. And to this day, we don't know where it was. It might have been modern day Somalia, it might have been modern day Yemen, it's very hard to tell. But the way that people have tried to track that is that they kept very good records of their voyage, and they brought back many different species, which they very accurately represented on the walls of her temple. So for one thing, you can tell that it wasn't a Nile voyage, you can tell that they traveled by the sea, because they represented the fish so accurately that ichthyologists can say that these are marine fish. So that's not quite the same thing, but it's in a similar vein. But yeah, most of the recreation was more symbolic. It was following their story of the creation, right? So it would be like if I had like a tomb that sort of like goes in one direction, goes deeper and deeper, and the deepest one is colored like the Big Bang, and then the second one looks like the Four Glowing Soup, and then the third one looks like, I don't know, the cosmic microwave background, and the fourth one looks like the Dark Ages, and the fifth one looks like the cosmic web, like representing our history of the universe. That would be an equivalent of being recreating the universe. As far as I know, it's mostly symbolic, or at least I can't think of a good counterexample right now. But yeah, the Poon stuff is really cool.
Right, I have 2 questions. You said you created a star maps back then, you have to account for their precession, but you have to also account for any stellar drift, or is it too small a time scale to account for?
It's mostly pretty small. So it's not the times. The time scale isn't huge, but also the corrections are small enough that I don't know that they would impact naked eye astronomy as much. So that's kind of where we win a little bit, which is that we don't need that much precision.
And how many stars overall did they catalog?
So in these Ramesside Star Clocks, they have 47 individual stars that appear. So that is sort of the magic number, or about the magic number that we are trying to get. So for instance, we found that if I always choose only the brightest star, I get like, depending on some other assumptions of where I'm looking and how narrow and stuff like that, but I get relatively few stars. I get like 12 stars. I keep seeing the same stars over and over again. And so that's, or if I'm too wide, then I keep seeing the same star because it hasn't left, like it repeats. That's the other thing that we see here. From row to row in a single table, the star name never repeats. So either it is narrow enough that the star has drifted out of view, or they never choose the same star again. So for instance, these are the kinds of things. A good question. There's a question here, and then you end.
Certain obvious star pattern help you modeling. For example, the Orion stars, the 3 dots in a line.
Well, but they only pick one star for every hour, right? So I don't know if it had 2 buddies next to it. Otherwise, that would be super helpful. I mean, I lost my mind the first time I saw what they call the bull's foreleg, because I'm like, oh my God, that's so obviously the Big Dipper. People have always made the Big Dipper into a constellation. But yeah, that would be super useful, but I don't have that information in this data. Yeah.
Yeah. I was gonna ask why so few stars, but it's 1 per hour. So.
Yeah, so it's 1 per hour, so it's 13 per table, right? Because 1 marks the beginning of the night, and then the end of the first hour, the end of the second hour, et cetera, until the end of the 12th hour, which is equivalently the end of the night. So you get 13 stars per table, and you have 24 tables, but they do repeat between tables. They just don't repeat within tables, which is an interesting pattern. So that's one of those things that you can try to recreate statistically. Sorry?
It's gonna make the mystery a bit harder to crack.
Well, it's helpful. I mean, maybe, but also on the other hand, it's nice to have more, I don't know, it's nice to have more things to try to match, because you don't want too many, because then you don't have anything, but the more we have, the more we can narrow it down. So hopefully we land somewhere in a sweet spot where we can tell at least a story, if not the definitive story. I think it was you.
Ramesside Star Clocks. What is Ramesside?
Ramesside, because they're all found in the tombs of pharaohs named Ramses. So what happened is that in addition to these time periods that I showed you, the eras were divided into dynasties, they were divided into dynasties. So the 18th dynasty ended somewhat acrimoniously. There was a guy called Akhenaten that you may or may not have heard of. He tried to do monotheism. They didn't like that. His son was Tutankhamun, and then everything sort of like went downhill real fast. And so the military stepped in and took charge and made peace. And the military general that then became pharaoh was called Ramses I. He ruled for a very short time, but then he had a son called Seti II, who was or Seti I rather, who was very successful, who had a son called Ramses II, who ruled for 90-something years, and it was like a golden age of Egypt. And it happened to be around this time where astronomically, the civil year, which is when Sirius rises in the morning, coincided with the agricultural year. And so this was a moment of order, which is important to the Egyptians. Not only were they strong politically and historically, it was a moment of celestial order. And so thereafter, you will see Ramses up to, I don't know what the maximal Ramses is, but like 18 or something like that. There are many Ramses. And so Ramesside is basically the era of this period when most everybody is called Ramses. And basically, the higher their number, the shorter the reign and more chaotic. So we think that maybe they were in some sense hearkening back to this legacy of not that long ago, thinking that if they could be just Ramses enough and ordered enough and astronomical enough, maybe there would be order and power again. Hence why Ramesside. That's a good question. I didn't explain that. Thank you. Yeah.
I was just wondering about those tables, whether they were ordered. Do we have an order for them, or is it still kind of randomized?
No, no, we have an order. It's like the first day of the first month of Ahet, the second day of the second month of Ahet, or the 15th day of the second month of Ahet. Whatever, they're in order. yeah. And it tells you like the first day, the 15th day, the first day.
And you mentioned this briefly, how the stars sometimes repeat from one table to the next. Has that given you any sort of insight towards, okay, maybe this star is this specific star because in my simulations it's coming back?
So we're very explicitly not doing that. So because we don't want to sort of like find a red herring and insist that, for instance, Sirius has to be in there and then like get hung up on that. So the idea is to abstract all away and look at just like the statistical distribution of the data.
Just how it looks.
Yeah, so like when I make like when I like just count the number of stars that are on the 0th bin versus each of the other bins, is that the same as for the real data set, or like close enough? Is that distribution about the same? Is it like tending towards the same distribution? Or is there the same number of individual stars or something like that? And so eventually, if we can narrow it down enough, we can play with that and try to make some speculations. But for right now, I think we're trying to be as like statistically obtuse as possible. And that's another place where the like random skies help, because in theory, I'm keeping all of the statistics, but I'm getting rid of all of my biases, or at least all of my biases that relate to certain named stars. Also, we named them what they're named as a Hipparchus catalog, and happily, I don't know what any of those H numbers are, so they can mean that much too. One there?
We have a question from.
Oh, sorry. Okay. Okay.
All right. I was wondering if you or people doing this archaeoastronomy have noticed these Egyptian star clocks in other cultures, because I guess at some point, I'm fuzzy on the date, but I guess at some point Egypt became part of the Roman Empire, and these things slowly found their way into other.
So not only do we not notice them in other cultures, we don't even see them in Egypt, right? You know, like seeing that little sketch of like, oh, there could have been a Ramesside star clock in another tomb that doesn't even give us any additional data. Like it's just like a circle. It's like a back of the envelope drawing. That was super exciting. So these things are a flash in the pan. They appear, they're really popular for like forebear, and then they disappear and never keep. So they're very bizarre that way. The closest I would say is what I said about the decans. So these are not the stars that appear in the Ramesside star clocks, but in the diagonal star tables from before. They seem to persist, but work in weird ways, where you have like King Solomon having to banish them, because each of them are demons and harbingers of different diseases, different specific diseases. So they stay in this like occult mysticism way. So they persevere in some way, but not a super obvious way, and not even necessarily astronomical.
Yes. So regarding the observational method used by Egyptians, is there any evidence of astronomical instrument in the archaeological records that?
To some extent, yes. I'm a little bit fuzzy on the details, so I won't postulate too much. But I would say, for instance, that the Karnak water is a good evidence of that. So there is certainly evidence of time. Stuff like that, which is sort of related. They didn't have like a telescope to the best of my knowledge or anything like that. But yeah, I don't have a great example off the top of my head, so I won't speculate, but I don't think the answer is none. I think the answer is I have to look it up. Sorry.
And another question, yeah. So you mentioned that different star tables span a period of about a millennia. eventually they could have encoded the session as well.
Yeah, potentially. So for instance, if you look at the diagonal star clocks that appeared around 2000 BC, and then the Book of Newt that references them and has diagonal star clocks as well next to it, or in around 10,000 BC. I'm pulling fast most of the days here, but there's about 1,000 years between them, so that would have changed the picture. So maybe that's why Ramesside Star Clocks happened. Maybe they were like, the stars can go. I don't know. But there's no. It seems to be the same data that is presented in 2000 BC and 1000 BC, which makes me think that it wasn't a new observation that was written down in the same way, but a copy of an old text that was passed down that had become religious and symbolic, rather than a new scientific, I'm not sure, writing down a new scientific data definition.
So there's no evidence actually of this session. I can by looking at.
Oh, I see. There could have been, not to my knowledge, there isn't. Maybe if we could identify some stuff from the diagonal star tables and compare them to the Ramesside Star Clocks, maybe we could find evidence of precession, which would be super cool. But there's many steps to that. And also that assumes that they were made at the same time, because for all I know, Ramesside Star Clocks existed for 2,000 years. And they've just, everywhere that they were written down, just happened to burn up in the Library of Alexandria or something. Absence of evidence is not evidence of absence, so that's kind of, we have a latest date, but not the earliest date, so it's all. And we'll go this way, yeah.
So how many different years do you have these clocks for, where it's like a unique year of observation?
They're not unique years, they're 4 copies of the same.
So it's 1 year.
It's 1 year. So it's 24 tables that span a year and 4 copies exactly, modulo copying errors, which because we have 4 copies, we have some idea of like what they were. Because that's nice. Sometimes you have a full data set, but then time decided to eat a chunk of your data set and you can never recover it, so you sit there crying. Thankfully, each of the 4 data sets is eaten differently, so we can recover 1 full data set. So the data isn't lost.
Like drift of data, like this one's more different.
So the only difference is within the 24 tables that are talking about different 15 days periods during the year. But between the 4 instances of them, they're the same, except when they were like miscopied. And sometimes we can tell that we were miscopied because in the hieroglyphic text, it says that, oh, it is above the right ear or whatever, but in the star is placed sort of on the wrong. So sometimes there's like a mismatch like that, and that just comes from being tired and copying a bunch of stuff leaving. So yeah, it's only 1 year of observation. Yeah.
I apologize if I'm the only one who doesn't know this, but today I heard the word decade the first time.
Oh, that's
what is it and what is it for?
No. Thank you for asking. That's a very specific thing. There's no reason to know it if you didn't know it before. So the decans are the stars that appear in the diagonal star tables, the older ones. They called them, they were named decans by Neugebauer and Parker, who were 2 academics who wrote the definitive books on Egyptian astronomy circa 1960. There's a 3-volume one. Yeah, there we go. Those are the chaps. And so there's like a 3 books of volumes plus 1 book of plates. They're incredibly hard to find, which is why we trade illicit PDFs with each other of them. But they are the ones that said, look, a new one appears every 10 days. Deca 10, therefore decans. So they named them decans and we're stuck with that naming convention. So that was their assumption, basically. But yeah, no, thank you so much for asking and for clarifying. Please, anybody else, if you have clarifications, please ask. Yeah.
Do you see, or has there been exploration of any evolution of thinking or increase in sophistication, or possibly a difference in what the whole thing is about between earlier and later? This covers a long period. And I wonder whether there are differences in not just sophistication, perhaps, but intention. Why we're doing this? Why are they interested?
Yeah, I guess to answer if there is evolution, I would have to answer that question for any single one of the instances, and I simply don't know what the intention behind it was. Definitely, if you looked at the Neugebauer and Parker books or something, and they catalog all this stuff, and you look at how each different text references stars or stellar phenomena or astronomical phenomena, either as just a reference in an otherwise mostly like, let's say, religious text, or, you know, in terms of, hey, there is some actual data here. They definitely talk about them differently, but each one is so different in the way that it appears and the way that it looks and sort of like the format that it is put in, that it is hard to say a lot about it. So for instance, in the pyramid texts, which are were first found in pyramids, and so that's what they are called, and were sort of popular funerary texts around in the Old Kingdom. They do, bless you, they do mention the imperishable stars a lot. So when the pharaoh dies, the pharaoh climbs up with the imperishable stars, which we interpret to be the circumpolar stars, the stars that never set, right? Because if you never set, you live forever. You don't have to worry about that cycle because you're always up there, you live forever. And then I don't see that as much in later periods, for instance. And so that's more of an ephemeral thing, right? That's not quite a piece of data or evidence that I would say, but there seems to be more of an emphasis on the northern sky in that sense, because that is where the stars that don't set live. Yeah.
Do all the stars that have been identified by ancient Egyptians correspond to some of what is today well known, or it has nothing to do?
I think probably yes, but we don't know because we don't know what most of them are. So I don't think that they invented new stars. I think they probably chose similar stars as the Greeks and the Romans, because, for instance, we like bright stars. We like stars that are, I don't know who asked about the belt of Orion, that are close together, right? That's cool. And so I imagine that they had the same interest, the same patterns interested them as everybody else. But we don't know what the mapping is. We don't have a translation between what they call their stars and what we call our stars today.
According to the position of the stars, it's not possible to say this star from the Egyptian period corresponds to this star today, or
not really, because I have to make a lot of assumptions. It's not specific enough, right? So I have to understand the method that they use to write down that data, to then reverse the data to put it on the sky, and then say, oh, if I compare this to what the sky looked like then clearly these match in some way.
nobody is intending to do that. Otherwise, it's
People have tried. A lot of people have tried, and a lot of people are trying. It's just hard. It's a lot of incomplete data. So we're doing sort of the best we can, right? And there's many ways to approach it. So this is one way to approach it. Another way is linguistically. For instance, how they called their constellations and how what they called their constellations changed, and how that's similar to what people living around them called their constellations. You know, so there's many ways to attack this problem, but it's not even looking for a needle in a haystack. It's looking for a needle in space. There's a little bit of data. It's not nothing to work with, but there's not a wealth of data. So we do the best that we can, and we try to be a little creative.
How are the today scientists using all that data, or they don't need to use it?
For identifying stars? Well, so
for understanding what the Egyptians saw.
So for instance, you can do what we're doing, right? And try to do some models and see if the statistics match. You can make some arguments based on religious ideas that were popular at the time. So for instance, if you go back to the diagonal star clocks that spend 70 days in the Duat, you say, the Duat is the other world. So they are in the underworld, they are underground. And at this latitude, they spend about 67 days being invisible, which is close. So maybe I built my model that way. And then you test that model and it works kind of, but not quite. And then somebody says, oh, but they refer to this star here and also here, but they use a different hieroglyphic sign for it. And maybe there is, that's the sign that's used in this religious cult, and maybe that's important. And so we sort of try to build up these pieces of information together. But if it were easy, somebody would have already done it.
I was more curious about the computation side.
Mm-hmm.
So, you have quite a few parameters, I guess, that you're modeling here. So how long does it take to run one simulation, and does it produce 24 tables in one run?
Yeah. So the long part is simulating the positions of the stars over a year. So basically creating the sky is the thing that takes long not the least because I didn't write it in the most elegant way and make it the fastest because I was okay with just letting it run in the background. But so that's the part that's a little bit onerous and that takes a little bit of time, and it produces a text file that's kind of large. Because you can do some optimization, but not so much. Ultimately, it's just making a big CSV file, right? When you want to read that CSV file in and then say, okay, assuming I'm looking south and my width is 10 degrees and I have equal bins and choose only the brightest stars, instantaneous. And so not only does the run produce 24 star tables, it produces 24 tables with all of the possible stars that are within those bins. And then from there, sub-selects it in different ways, which we call our choice algorithms. So one shows me only the brightest stars. One shows me only the stars that have appeared before. One shows me the star that is the closest to the center of its own bin. So because they're on those lines, it seems to be a very precise position. And then one shows me some bespoke selection algorithm that Sarah and I discussed. And the idea is if you run enough of these and see how the statistics change, then maybe you can start to converge on some ideas. Yeah, exactly. And so what we're doing right now is we're testing the model that Neugebauer and Parker put forth, which is that they are looking due south and they're observing the transitive stars because they were like, yes, there's only one reasonable thing to do, which is to look south at the celestial meridian because the stars are transiting and so they're up high and so you don't have to worry about horizons and they're going straight across, and that's a great way to do it. And sure, yeah. Did they have a concept of the celestial meridian? That's not clear to me. And maybe they did, but I don't have evidence of that. And so, yes, I agree. That's a rational way for us to construct a star clock. But I don't know that it's quite, that it comes out of the same milieu as they might have, right? And so I'm happy to test it, and if it works, that's great. And maybe that is what it is. But I'm also happy to perturb around it and test other ideas. There's a lot. Okay, let's go there and then.
So going back to the Ramesside Star table, there's like a rhythm that divides it.
Mhm.
And I was just wondering if we knew if that had any like symbolic, was it an observation or was it a story of some celestial event, or like do we know what it?
No, it tells us about this person who's caught. So for instance, that one belonged to the high priestess Ashes. So it says, it says her name and it says her titles and it glorifies her and pushes her, Fuja Seneb and, health, life and dominion forever and stuff like, it's funerary forms, right? So it identifies the person. If you like, it's like the equivalent of a hint sense. So that is information about the person specific. Yeah.
Can you talk about the field of research that you open up if you are successful in decoding this?
The field of research, well,
what kind of things would be open?
Yeah, so here, my dream scenario would look something like this. That we are able to narrow down the methods sufficiently, or that we are able to produce a compelling case for a narrow enough type of method to match the statistical data, that we can sort of try to then take that and reverse it, which is to say, take their data and project it onto the sky, and then maybe try to make have some information about which star belongs to which modern star, like make a translation, let's say, a translator between their star names and the star names that we know and love, for instance. And then maybe that informs us about how we approach these other types of star data. And so I don't know. It's hard for me to speculate about whether this would open like a huge field of research within this, subfield, because the subfield itself is quite small.
It would help dating certain stuff.
Maybe potentially, I guess. Maybe it would help us date when the original observations were done, right? Because we don't know that. We know when we first saw them, but for all we know, they were done 1,000 years prior, and they just dug it out of some attic and were like, "Hey, Jimmy, what about this one for the new tomb? Yeah, ship it." So we don't know, but yeah, that might be one way to do it. I just think it would be really fun to give the stars their Egyptian names back. Like if I had a really reach goal, that would be my goal. But I think we might always have a little bit too much noise to be able to say that with any level of confidence. But maybe we can hope and speculate. And the code that I built that sort of like simulates the sky around this time and then does these sort of like statistical models for Ramesside Star Clocks is open source. So my plan is to make it a little bit prettier and make it accessible to anybody in archaeoastronomy who maybe wants to add a module to do statistical data on a different data set in a different year PC or something like that. Because if that's useful to somebody else, that would be great. So that's my other slightly less reached dream, let's say. For their other hand, yeah.
Just curious if there are observations of the planets, if it's showing up in the same ways as the observations started.
They're not quite observations, they hang out in certain diagrams that they have, but it's sort of somewhere between like a map and a sketch, so it's a little bit hard. They also kept drawing the sky as a square, which puzzles me to no end, and I think it's very, yeah, so there's one astronomical ceiling of Senenmut, who was a counselor, or a high vizier during the time of Hatshepsut, the woman pharaoh, for instance. And he has this really beautiful astronomical ceiling, and if I remember correctly, the planets appear there, but they're just little dudes with cool heads hanging out in boats. They were all in boats because the sky is water, everybody. Like the sky was always water. And so they're in boats because they move across the sky in a way that stars don't. Stars are fixed to the celestial firmament, as they say, but the little boat guys can just swim around because it's their fun to swim around it. So it's not quite an observation. It doesn't tell me which planet it was, but they're there. They knew about the inner planets.
And like tested, or was it just taken out like through certain years and it kind of delayed?
It wasn't so much for certain years. I think it was, as far as I can tell, and I'm not an expert on this, but as far as I can tell, it was more of an artistic whim than a certain year. So they don't appear in every single piece of astronomical, let's say, depiction, whether it's sort of for funsies or for religious purposes or for like data. But neither does anything else. Nothing appears everywhere. So they were certainly aware of them, and they had names, and they were like fundamentally qualitatively different with stars, but they sort of appeared, I think, when they wanted to. They were like cats. Yeah.
Another question on YouTube. So can you take into account the fact that the star drifted, like the motion of the star changed with time? Or is it like a negligible effect of it?
Yeah, so we account for the precession of the equinoxes, which moves all of the stars basically the same way all the way back. We don't worry too much about the drift of individual stars because their proper velocities would be fairly small. It would be important if you're pointing like the Hubble Space Telescope at them. They're not that important if you're pointing your eyeballs at them, so we don't worry about them too much. And if one of them did a weird thing that we don't know about, then we don't know about it, so we can't account for it. So at least for naked eye astronomy, we think we're okay. Yeah.
Kind of religion or culture and shit, there's bias and like what they decided to observe or absolutely just with this.
Yeah, absolutely. The same way that, my culture introduces the bias, I'm like, oh, clearly they knew what the stellar meridian was, and clearly that's sort of the answer. Yeah, 100%. I mean, it's a coherent story, and it doesn't come out of nowhere, right? And so I think that's important to take into account, / it is important to understand the level to which we can't take that into account. And I think cultural, this is sort of a tangent to your question, but I think cultural memory is something that hasn't always been taken into account the way it should have in archaeology in general and Egyptology in particular. So I have a very vivid memory of going to a talk by Mark Lehner, who has a lot of books out, and they're very cool. I recommend them. He's famous because he has been excavating up the Giza Plateau by the pyramids, by the Great Pyramids, for a very long time. And so it was this Egyptology conference, and he was like the 8 a.m. talk, and everybody showed up anyway because we all wanted to hear about what was seen at the pyramids. And he was telling us the story about how they were excavating one of the temporary villages where the workers lived, not the enslaved people, where the workers lived. And so they found a bunch of remnants from like middens, from trash, basically, which archaeologists love. The only thing we love more than trash is poop. Poop is great. You get so much information. But anyway, so they found a bunch of long bones, so like your femurs or shins or something from cows, right, with the ends cut off. And they were like, what the hell is up with this? Why were they cutting off the ends of all of the arm bones? And so they were sort of like standing around and scratching their heads. And then they mentioned this to a few of the conservators that were working outside, who were Egyptians. And they all looked at them and went, duh, shodet kuwer. And they were like, yani shodet kuwer, what is shodet kuwer? And it's knuckle bone soup. It's the way that you keep your muscles strong if you're lifting heavy stuff. Or for instance, if you're training with the all-athlete football team, which they do to this day, which is like one of the 2 Cairo football teams that is the more famous one. So like this is completely a cultural practice that maintained to the point that it never occurred to anybody to question it, but the archaeologists were standing around scratching their heads. The archaeologists who aren't Egyptians were standing around scratching their heads. And so, I don't know, for all I know, there's like a piece of family lore somewhere passed down that like provides a really interesting story. The other thing is there's a famous Egyptian story that is like on a papyrus, and everybody who learns hieroglyphs has to learn it and translate it and all of this. And the end was lost and thought it was this like big philosophical piece. It's called the man arguing with his Ba. That's not exactly the title, but the man who argues with his Ba, which is his soul. And he's tired of living, and so it's this Greek existential text. Oh my God, we discovered Proustianism before Proust and stuff like that. And then, but we never had the end of the story. And then one day somebody found a papyrus between some books in like a convent in Cyprus or something. These are all approximate answers, but that was the vibe. And so they found the end of the text and they translated it, and no, his girlfriend broke up with him and he was really sad. So there's always the possibility of either a bit of cultural knowledge or a bit of like physical knowledge being lost somewhere and found again, especially with all the stuff that is stolen from Egypt. So yeah.
Amazing. So I think we can end the Q&A session. And first of all, I would like to thank Luna Zagorac for this beautiful talk. So
Thanks everybody.
Yeah, and so I would like to take 1 second before the battery of the computer dies to introduce the next public talk, which is going to happen on January 15th. So it's going to be a panel discussion on exoplanets with Professor Jonathan Garnier from the University of Montreal and Casey Brinkman, who's a TSI postdoctoral fellow. So join us for this event. Another thing, so we're going to have actually a public observing night outside. It's going to be very cold, but Sam should be outside with a telescope next to the lower field. So you should, like, when you get out of Leacock, you should turn to the right and you should see her eventually. So yeah, I had attached the map to the email. And last item, so if you enter the raffle and your name is either Amira or Conrad, then you have won physics mug, which is very cool. And yeah, I would like to thank you again. I would like to thank you for all this very engaging discussions and questions, and I really hope you enjoyed the talk. And yeah, thanks again. Yeah.
Yeah, I was a little worried about that, but I'm glad we got it just under the wire.
Thank you so much. This is a very long Q&A session, but like
I kind of lost track of time, so I had no idea how long I was talking for. So I hope it wasn't too long.
No,
Congratulations on that. You have a whole more information. And so enthusiastic.
Thank you very much. I really treasure it.
Oh, many quotes. Like literally never heard anybody so enthusiastic as this information. I love your whole attitude.
What can I say? I love attention.
I do understand.